So, what we have done till now? We have calculated del P, we know del Q, we know now del delta and del V, and this way we can calculate the elements of Jacobian matrices. The matrix, the elements are J11, J12, J21, J22. So, corresponding to a specified quantities, the left hand side quantities, we are having del P and del Q. So, we can calculate it assuming certain initial values of delta and V, and we know del P is the difference of specified quantities and calculated quantities. So, we know this, and at initial values we can get the values of the elements of Jacobian matrix J11, J12, J21, J22. So, on right hand side del delta and del V vectors are unknowns, corrections required. So, these quantities are required to be calculated in terms of these quantities, and the corresponding unknowns will be updated. So, now we will discuss the simplified version of J11, J22, how to calculate J11, J22, because it seems to be lengthy. So, we will try to simplify the calculations for the elements of the Jacobian matrix. So, we can have J11. So, J11 corresponds to del P del delta. So, in general del Pi upon del delta J. So, these I and J may or may not be equal, sometimes they are equal, sometimes may not equal. So, consider the case when I is not equal to J. Suppose del P2 del delta 3 or del P7 del delta 9. Later we will consider when these two are same, that is del P2 upon del delta 2 or like del P5 upon del delta 5 separately. So, first we will try to simplify the calculations corresponding to these elements. Again recall the relation we denoted by equation A to calculate the active power flow into the ith bus. The active power injected at ith bus Pi is given by what we wrote earlier, Vi summation k equal to 1 to n Yik Vk cosine of theta ik plus delta k minus delta I. We know Pi. Pi is function of Vi and delta I. So, we have to differentiate, we have to take partial derivative of Pi with respect to delta J. So, right here we can write del upon del delta J, write this complete Vi k equal to 1 to n Yik Vk cosine of theta ik plus delta k minus delta I. This. Please note here, all the terms independent of delta J will vanish and only term or terms containing delta J will be useful here. So, we can segregate these terms. This further can be written as del upon del delta J. Take the first term will be corresponding to k is equal to 1. Take Vi, Vi is constant for delta J together, and first term will be yi1 k is equal to 1 v1 cosine of theta I1 plus delta 1 k is equal to 1 minus delta I. We will not see any delta J here. So, this is independent of delta j plus second term we can write yi2 v2 cosine of theta i2 plus delta 2 minus delta I plus so on. Write jth term. Jth term is k is equal to j. So that will be yij vj yij vj cosine of theta ij plus delta j minus delta I plus next term write here nth term. Nth term corresponding to k is equal to n. So write here yin vn cosine of theta in plus delta n minus delta I. Take vi and first term 0 independent of delta j plus 0 plus so on plus jth term. So here we are having delta j and cosine of minus sign. So minus sign will be there and delta is there. So directly we can write in bracket we can write minus yij vj and first derivative of this minus sign we have taken sine of theta ij plus delta j minus delta I. Okay. Take this plus sign is here to avoid confusion write this plus here dot 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 all 0 we can write 0 plus 0 dot plus this is also 0. So only one term non-zero term we will get. Thus we can write del pi del delta j I is equal to not j will be equal to minus sign vi this vi yij vj sine of theta ij plus delta j minus delta I. We can write this. So in order to calculate the elements of Jacobian matrix, instead of calculating that lengthy procedure, we will follow this. Suppose del P2 upon del delta 3. So directly put here I equal to 2, j is equal to 3, put the corresponding values here. We know for P2 we will get here V2 and similarly the elements of Y bus matrices we can calculate del Pi del delta j and thus our calculations will be satisfied. So take the another case when I and j both are same, that is del P2 upon del delta 2 or del P5 upon del delta 5 etc., del Pn upon del delta n like that. So we will follow the similar procedure. We will start from here. So next we are trying to calculate del Pi upon del delta j for I equal to j, that is del Pi upon del delta I. This can be written as del upon del delta I. Write here again the formula for Pi, that is Vi summation k equal to 1 to n Yik Vk cosine of theta I k plus delta k minus delta I. This can be further written as del upon del delta I. Write the first term. Again here we will write ith term separately because the ith term or jth term behaves differently from the other terms. That is why we are segregating these terms. So, first term will be Vi, take common as Vi is constant for delta I. First term yi1 v1 cos theta I1 plus delta 1 because k is equal to 1 delta 1 minus delta I. First term plus second term yi2 v2 cosine of theta I2 plus delta 2 minus delta I plus so on. Write ith term here. So, ith term will be k is equal to I. So, that will be yi k is equal to I vi cosine of theta I minus k is equal to I. So, delta I minus delta I ith term plus so on plus nth term k is equal to n. So, this will be equal to yin vn cosine of theta in plus delta n minus delta I. Now, here the ith term is independent of delta I because these two get cancelled. All other terms behave differently than ith term. So, ith term becomes independent of delta I, but other terms are depending on delta I. You can see here everywhere delta I up to nth term delta I except ith term we will get delta I. So, this can be written as, so again cosine first derivative minus of sine and this is negative, so minus sign get cancelled. So, directly we can write Vi constant, these two yi1 v1 sine of theta I1 plus delta 1 minus delta I. First term. Differentiating second term with respect to delta I. So, again minus sign of this and this minus sign cancels. So, plus we can write yi2 v2 sine of theta I2 plus delta 2 minus delta I plus so on. So, for ith term this is independent of delta I, so 0 and the remaining non-zero terms can be written in similar way plus write for nth term yin vn sine of theta in plus delta n minus delta I. We can write this. The same can be written as, we will write here, the same can be written as equal to, this will be equal to all terms except ith term we can write yik vk vi summation k equal to 1 to n and we are not having ith term. So, write here k is not equal to I because ith term is 0 yik vk from nth term itself we can write yik vk sine of theta ik plus delta k minus delta I. except ith term we are having this. So, add ith term and subtract. So, this can further be written as, I am rubbing this one, I am including this ith term here and subtracting here directly. So, first subtract and then we will remove. So, next term will be this one minus ith term will be yii vi sine of theta ii, ith term will be having k is equal to I plus delta I minus delta I, that is 0 right here, and remove here because we have subtracted this term. So, we have included in this, that is why removing this one. See the equation B, that is equation for Qi. Qi is negative sign here and the same yik vk sine of theta ik minus plus delta ik minus delta I. That is why we can write here minus Qi for this minus. Now, this can be written as Vi Yii sine theta Ii. What is Yii sine theta Ii? Remember, during formulation of Y bus, we denoted Yii as magnitude Yii and angle theta Ii. That can be written as Yii cosine of theta Ii plus j times Yii sine of theta Ii. So, Yii is nothing but G plus JB, Gii conductance plus j times substance Bii. So, Bii is nothing but Yii sin theta Ii. So, Yii sin theta Ii can be written as, this can further be written as minus Qi minus Vi Bii. This is del Pi upon del delta I. So, this is the simplified method to calculate J11, whether I is equal to J or I is equal to not equal to J. Directly we can substitute the corresponding values and we can evaluate the elements of these two matrices. So, this way we can calculate del Pi del delta J. One more thing, we have included kth term here, ith term. So, we have subtracted and this term is having Vi and Vk both. So, for k is equal to I, this will be Vi square, correct it, Vi square. So, here we will get Vi square, fine. So, here Vi square, okay. This term was added and subtracted together and this term is having Vi, Vk both terms. So, for ith term k is equal to I, this will be Vi square. So, this way we have calculated J11. Next, for J12, calculate J12. So, J12, one from left hand side and two from right hand side. So, that will be del P upon del V. So, right here del P upon del Vj, first take I is equal to not J and then we will take I is equal to J. So, del P upon del Vj, right here del Vj, okay, same thing del Vj. This time we will focus on jth term. So, this is first term, this is second term as it is, and jth term put here Ij, k is equal to j. So, Vj, wherever k is there put j. So, Vi is outside and Vj cosine of theta Ij plus delta j minus delta I, and this is Vj. So, correct here Vj. So, all other terms except jth term are independent of Vj. See here. So, this will be equal to 0. I will rub this. So, here we can write Vi outside constant independent of Vj. So, first term is independent of Vj 0, second term also 0, okay. Write third plus 0 plus so on. Jth term, here Vj is there, so we will get this is plus, right, theta I k plus delta k minus delta I, okay. So, here we will get plus Yij Vj. With respect to Vj, we are not having Vj now, cosine of theta Ij plus delta j minus delta I plus 0 plus so on 0. We are having just jth term here. This way we can write del Pi upon del Vj, this I is equal to not j is equal to Vi is here times this Vi minus Yij cosine of theta Ij plus delta j minus delta I, the simple one. Next, when I is equal to j, I is equal to j, so this will be equal to Vi itself. So, this will be equal to I, put Vi is equal to Vj equal to Vi, the same equation of Pi. So, here we will try to segregate the terms so that we will get ith term separately, because ith term will behave differently than the other terms. So, this time this is Vi and here we are having Vi. So, all terms are depending on Vi. Vi. So, all terms are depending on Vi. So, right here ith term Yii, again one more Vi is here, that is Vi into Vi square term will be there in ith term, that is difference between this term and other terms. So, this time this will be same, because it is Vi and we are differentiating with respect to Vi. So, this term will be as it is right here. What we will write for first term Yi1 V1 cosine of theta I1 plus delta 1 minus delta I, first term. Similarly, second term we can write Yi2 V2 cosine of theta I2 plus delta 2 minus delta I, and so on, third, fourth. For ith term we are having Vi and Vi, so Vi square, so that will be twice of Yii, this Vi cosine of theta, okay, this was ith term, so here it will be Ii delta I. So, theta Ii you can write and subtract the same delta I minus delta I to avoid confusion, and plus so on nth term as it is Yin yin Vn cosine of theta in plus delta n minus delta I. Fine. Take all terms together. So, this can be further written as is equal to, we are having all terms, but I a term twice of this, the same quantity. So, take one term together and one term separately. So, that can be written as y I k v k cosine of theta I k plus delta k minus delta I. We have taken this one term together and one term separately. Take summation sign, k equal to 1 to n plus, I will rub, okay, plus we can write the single term yi vi cosine of theta ii. See the equation of pi. These terms are exactly same as these terms except vi. So, this we can write pi upon vi plus yi cos theta ii. See here, yi cos theta ii can be written as gii. So, plus vi g ii. This is del pi upon del vj, I is equal to day, directly we can write del pi upon del vi. Fine. Any doubt here? So, this way we have calculated J11, J12. So, next we will calculate J21. So, again J21, second from left hand side Q and first one from the right hand side delta, del Q upon del delta. So, we can write here for J21 we will get del Q I upon del delta I. Take the case, take J, I is equal to not J, first take I is equal to not J, then we will take I is equal to J. Okay. First one, second one, okay. So, write here Qi, this will be del Qi, same thing upon del delta J. So, del upon del delta J and equation of Qi, minus sign is here and all other terms are same except here we are having sign. See equation B, equation for Qi. Fine. So, we have to evaluate del delta J for Qi. Right here del delta J, minus sign is here, segregate the terms and everywhere we will get sine instead of cosine, sine here, second term corresponding to k is equal to 2 and jth term we will write here jth term. So, ij vj and sine of theta ij plus delta j minus delta I, and the nth term yin vn sine of theta I n plus delta n minus delta I. So, this time we are writing for delta j. So, except jth term, all terms are independent of delta j. Say delta 1 is independent of delta j. When it is differentiated with respect to delta j, it will give 0, 0. This only will give non-zero. Delta j is here. So, delta j, so sine, it will be cosine, minus sign is here. So, this can be written as take minus Vi outside, minus Vi outside, first term 0 plus 0, second term write at corresponding places to avoid confusion, plus 0 and so on, plus jth term. So, delta j sine cosine will get Yij Vj cosine of theta ij plus delta j minus delta I plus 0 plus 0. So, we will get del qi corresponding to j21 del qi upon del delta j, condition is I is equal to not j, will be equal to minus Vi times this, minus Vi Yij Vj cosine of theta ij plus delta j minus delta I. Next, we will write thus delta qi upon del delta j for I is equal to not j can be easily evaluated. Suppose we want to evaluate the elements corresponding to j21, say del q5 upon del delta 3, because I is not equal to j. So, directly take I is equal to whatever you are taking, j is equal to whatever you are taking corresponding value, substitute here, directly we can get, that is easy for us. So, the next, when I is equal to j means del q2 upon del delta 2 or del q3 upon del delta 3 and so on, for I is equal to j, right here del qi upon del delta j for I is equal to j, we may write this will be del delta I. So, instead of jth term we will focus on ith term, and here we will write I. So, wherever j is there we will write I, because we have to focus on ith term this time for delta I. So, first term, second term and ith term. So, right here ith term will be corresponding to k is equal to I, and k is equal to I, this will give Yii Vi sine of theta I plus delta I minus delta I. It means ith term will be independent of delta I, other terms will depend on I. So, this time we will write here minus Vi, fine. First term del delta I, sine corresponding to sine we will get cosine, and minus delta is there. So, again minus, so that minus will get cancelled. So, we will get plus Vi and Yi1 V1 cosine of theta I1 plus delta 1 minus delta I. Similarly, second term we will get cosine of this, and minus sign already we have taken care. So, the second term will be equal to yi2 v2 cosine of theta I2 plus delta 2 minus delta I. Similarly, we can write third, fourth. What about ith term? Ith term is independent of delta I, hence that will be equal to 0. So, write here at corresponding places. So, for this the places here write 0, and the other terms are non-zero. So, similarly directly write the nth term. Again nth term is having delta I. So, cosine minus sine already taken care. So, write here y in v n cosine of theta I n plus delta n minus delta I, middle bracket. This way we can write this is equal to all terms except ith term. So, Vi take outside, Vi take summation sign, k equal to 1 to n, and we are not having ith term. So, k is not equal to I. Yik from nth term itself we can write Yik Vk, Yik Vk cosine of theta Ik plus delta k minus delta I. Again add and subtract ith term. So, we can add, we can remove this because we are adding ith term. So, we have added and subtract. So, minus subtract ith term, that is Vi directly Yii cosine of theta Ii, right here Yii cosine of theta Ii. This is ith term because delta I minus delta is 0. Again Yi cosine of theta Ii, Yii cosine of theta I is Gii. So, Gii Vi, how many Vi? Again Vi square, because Vi is already there and k is for ith term k is I. So, Vi square. So, we can write this. What is this? Pi. This is nothing but Pi. Pi this whole term minus Vi square Yii cosine of theta Ii, we can write Gii. What we wrote? Corresponding to del Qi del delta I. Del Qi upon del delta I can be written as Pi minus Vi square Gii. So, completely we have written the terms for J21. The last one is J22. Following the similar procedure for J22, second from left hand side and second from right hand side, we can write del Q upon del V. So, instead of delta write here V. Del Qi upon del Vj, I is equal to not j. Take the first case when I is not equal to j. Later on we will see when I is equal to j. That is for 2 2. Del Q upon del V. So, del Qi del Vj, I is equal to not equal to j. Right here del Vj. So, here we have to focus on j term of Q, Qi. So, for Qi we have this relation already written, just we need to modify here Vj and we have to focus on jth term. So, first term will be as it is, second term will be as it is. Instead of ith term we will write jth term. So, that will be Yij Vj sine of theta Ij plus delta j minus delta I. And the nth term yin vn sin of theta n plus delta n minus delta n. So, this time also the behavior of j term will be different than the behavior of other terms. Say Vj, here no Vj, so independent of Vj 0, second term, except j term all terms will be 0 here. So, right here what about j term, we are having Vj. So, directly we can write this, okay, outside this is minus Vi, first term 0 here, second term 0 here, we are writing at corresponding places. So, other terms are also 0, but this time j term is equal to, with respect to Vj it will give Yij, Vj is gone sin theta ij plus delta j minus delta I. And what about other terms? 0, right here 0. Only j term is non-zero, other terms are 0. So, we can write this time we can write del qi upon del Vj, condition is I is not equal to j, is equal to minus Vi Yij minus Vi Yij sin of theta ij plus delta j minus delta I. So, this time also in order to get the terms corresponding to the Jacobian element J22, when I is not equal to j, directly we can substitute the values and easily we can get it. Like for here I is not equal to j, so suppose del q3 upon del v9. So, directly take I is equal to 3, j is equal to 9, substitute the values, easily we can get the corresponding element of J22. So, the last one, that is when I is equal to j, we will evaluate del qi upon del vj, where I is equal to j. Suppose del q2 upon del v2 or del q5 upon del v5, like that, for that. So, this time this is nothing but equal to del qi upon del vi. So, put here I, and following similar procedure we will write, we will focus on ith term of this. So, del upon del vi first term, second term, and then ith term. So, Yii Vi sin of theta ii delta I minus delta I. Put I k is equal to I here. So, Yii Vi sin of theta ii, wherever k is there put I. So, we have written ith term and so on. So, nth term Yin k is equal to n Vn sin of theta In plus delta n minus delta I. This time our variable is Vi, and Vi is everywhere in all the terms. In ith term we are having Vi into Vi square. We have to differentiate the terms with respect to Vi. So, right here this will be as it is, only Vi is there, and this will be equal to twice of that. So, minus, write all terms yi1 v1 sin of theta I1 plus delta 1 minus delta I, first term, then second term plus yi2 v2 sine of theta I2 plus delta 2 minus delta I. Second term we have written, and so on third term. For ith term, we are having Vi here, minus sign is already taken outside. So, Vi square, so that will be twice of Yii Vi square. So, twice of Yii sine of theta I plus delta I minus delta I, that is 0, plus so on, plus nth term Yin Vn sine of theta In plus delta n minus delta I. So, this can further be written as minus sign outside. We are having ith term twice of this. So, take one term with this as it is in accordance with this Yii Vi sine of theta I delta I minus delta I. So, one term will be outside and minus sign is there. So, outside term will be also negative. So, right here minus k equal to 1 to n y, from nth term we can write Yik Vk sine of theta Ik plus delta k minus delta I, and remaining one term of ith term, minus sign is outside, we can write minus Yii or Vi, take first Vi Yii sin theta Ii, delta I minus delta I is 0. So, Vi Yii sin theta Ii, and sin Yii sin theta Ii we can write Bii. And what is this? What is this? See, minus sign is there, only Vi is missing, other terms are as it is. So, we can write this as Qi and Vi. So, Qi upon Vi. This term can be written as Qi upon Vi, and this minus Vi. Again, see something we are missing. Oh no, this time not missing, exactly outside. Okay, fine. So, ith term is Vi only. So, Vi sin theta Ii. So, right here Vi and Yii sin theta Ii will be equal to Gii. So, this will be equal to del Qi upon del Vi. Seems to be lengthy, but it is very easy. The main problem is calculation of Jacobian matrices here. Calculation of specified quantities, changes in specified quantities is not so tough. So, once these two matrices are known, we can evaluate these correction matrix. We can say this column matrix as correction matrix in terms of these two known matrices, now known matrices. Once these corrections are known, so we can update in each iteration, calculate the unknowns, corrections, and update with the previous iteration values. Suppose initially you have assumed for PQ buses delta 20, delta 30 up to delta n 0, and for V delta V20, V30 up to Vn 0. So, in first iteration you will calculate del delta 1, del delta 0, del V0. So, the values will be updated. Now, del delta 1 will be equal to del delta 0 plus delta 0 initially assumed value. Similarly, we will discuss in lectures followed. The next lecture we will consider the PV buses also. This time we considered only PQ buses, means apart from slack bus, all the buses from bus number 2 to n are PQ buses. Later in next class we will consider when PV buses are also present. Oh, one more thing, YII sin theta II here, YII sin theta II is BII. So, modify it as BII. By mistake we wrote GII, this will be equal to BII. Thank you.